Example 4 says the sales decay for a product is given by S equals 50,000 times e to the power of negative 0.8 times x, where S is the monthly sales and x is the number of months that have passed since the end of a promotional campaign. Part A says, what will be the sales 4 months after the end of a campaign? So what we want to do is we want to plug in 4 for the x value. And I threw that into my calculator and got that that was approximately, after 4 months of the campaign, then the monthly sales would be $2,038.11. Part B says, how many months after the end of the campaign will sales drop below $1,000 if no new campaign is initiated? So we would want to take our function and set it equal to 1,000. And our goal is to try to solve for x. So I'm going to divide both sides by 50,000. Let's see, if I simplify that and cancel the zeros, that would be 1 over 50. Now I can take the natural log of both sides. Notice that I'm taking the natural log this time since the base that I'm looking at is e. And the power rule for logarithms says that I can take the exponent and bring that on the outside, and then I would multiply that by the natural log of e. And ask yourself, what is the natural log of e? If you don't know what it is, practice, because you want to get to a point where you're like, I know what the natural log of e is, and that number is 1. So that's going to simplify to negative 0.8x is equal to the natural log of 1 over 50. If I divide by negative 0.8 on both sides, now x is a number of months. And so if our numerator here ends up being a positive number, we just divided by a negative number, so that's not going to make sense. We need it to be positive. So what that says is that the natural log of 1 over 50 has to be a negative number, which it will be. But if you don't believe me, plug that into your calculator. So if you throw that value into your calculator, you should get about 48.9. I'm going to round that up to about 49 months after the end of the campaign. Okay. Example 5 says Mr. Kwan opens up a savings account that has an interest rate of 5.2% compounded weekly. If Mr. Kwan initially invests $4,000, how long will it take for Mr. Kwan's savings to reach $6,000? So the first thing that we want to do is we want to create our exponential function. So let me give you the formula that I gave in a previous video. S is equal to P times 1 plus R over M to the power of M times T. So S is equal to, P is our principal amount, or the amount that we initially invested, times 1 plus R is our interest rate as a decimal, so that's going to be 0.052 divided by M represents the number of times we are compounding in a year. So if we are compounding weekly, and then our exponent contains the M value again, and we multiply that by T. So now we want to figure out how long it's going to take my savings to reach 6,000. So I'm going to set my function, I'll just erase that part and set it equal to 6,000. And I'm trying to solve for t now. So I'm going to divide both sides by 4,000. And if I do that, I get 1 plus 0.052 divided by 52 is equal to 3/2. Now I'm going to take the log of both sides, and I'm going to skip a step and incorporate the power rule for logarithms, just because it's a lot of writing. Okay, now I'm trying to solve for t, and I have a bunch of multiplication here, so I'm going to divide both sides by 52 times log of that gargantuan monster. So if I do that, then we'll get t is equal to log of 3/2 divided by 52 times log of 1 plus 0.052 divided by 52. And let's see what we get when we throw that into our calculator. So I plugged that into my calculator and got t is approximately 7.80 years. So that's the amount of time that it'll take for my savings to reach $6,000. Example 6 says, Mr. Kwan buys a used car for $11,000 and every year it depreciates by 9%. Find the value of the car after 10 years. Now, in a similar scenario where if I said that it appreciates by 9%, that is that the value of the car is increasing by 9% every year, we saw an example of that where we would need if we had our exponential function looking like this, our b value in that scenario, if it was increasing, it would be 1.09, because I said that you had to add 1 to whatever the percentage was. However, it's different if the value or the population or whatever you're measuring is decreasing by a certain percentage every year or time interval that you're looking at. What you would do in that scenario is you would do, instead of adding, you would do 1 minus whatever the percentage is as a decimal, which in this case, if we did 1 minus 9%, that would be equal to 0.91. So in this scenario, our b value is 0.91. So the car has a starting value of 11,000, and since the car is depreciating by 9% every year, that means that every year it's keeping 91% of its value. So our function is going to look like that. And if we wanted to figure out what the value of the car would be after 10 years, we would just replace t with 10. So plugging that into our calculator, we get approximately $4,283.58. So that will be the value of Mr. Kwan's car after 10 years.